Pump stations, parallel operation. How multiple pumps combine to increase flow capacity. Every centrifugal pump has a characteristic curve. Head decreases as flow increases. At zero flow, the pump reaches its shutoff head, 52 meters. As flow increases, head drops following H equals a minus B times Q squared. This is the fundamental relationship between head and flow. But what if one pump isn't enough? Connect pumps in parallel. Each pump sees the same discharge head, but the flows add up. Total flow equals the sum of individual flows. To build the composite curve, pick a head value. Find the flow for each pump at that head. Then add the flows together. At 40 meters of head, each pump delivers about 31 liters per second. 2 pumps, 63 liters per second. Repeat at 30 meters. Each pump gives 43, together they give 86. At 20 meters, 52 becomes 103. At 10 meters, 59 becomes 118. Connect these points, and the composite curve emerges. Here's the result. The dashed line is the single pump curve. The solid line is the composite curve for 2 pumps in parallel. Notice how the composite curve shifts to the right. More flow at every head. The shutoff head stays the same because at zero flow, adding pumps doesn't increase pressure. Real pump selection goes beyond the HQ curve. You need to check efficiency. The best efficiency point, or BEP, sits at 25 liters per second. You also need the NPSHr curve. It rises with flow. Always verify that available NPSH exceeds the required NPSH. All of this is built into FlowAnalyzer. Set up 2 pumps in parallel and instantly get the composite curve. Add up to 4 pumps, see the full system view, and find the operating point where the pump curve meets the system curve. FlowAnalyzer Suite, hydraulic engineering tools. Visit app.flowanalyzer.io. See you in the next video. Thanks for watching.